triangle, you can.
You should do that more.
Should have been right over the top of your head.
Oh, yeah.
That was Andrew's dressing here.
One move and it's all over.
All right, so both of these are based off of what we did on Friday. These both have the same formula. Big B times H, okay? The one thing that I'm going to keep stressing, you're probably going to get tired of me saying, is we have to pay attention to the base. The base is going to tell me everything. All of these problems, on Friday we talked about all kinds of different prisms, but what was different was the base changed. Some were a triangle, some were a rectangle, maybe a square, all different kinds of bases. We saw one that was a trapezoid even, okay? My bases are going to change. It's the same formula, and so what I think is helpful, I'm going to do the one on the right first. This would be kind of like, I kind of think of it as like a cereal box, kind of what it looks like. My base is what kind of figure? A rectangle, okay? We have a rectangular base. So big B is a rectangle. I would get in the habit of identifying that base the very first thing that I do on all of these problems, okay? Identifying what that base is. Because this is a rectangle, the area for a rectangle is simply just length times width, okay? Or base times height if you want to do that. I like using length times width. So this would be 10 times 4 times 12. Okay? It's pretty simple, right? You're just multiplying the 3 dimensions. You might even remember this from when you've done 3-dimensionals before. Length times width times height. Okay? Multiply the 3 dimensions together. But when you did 3-dimensionals, probably back in middle school, you didn't really look at a lot of different bases. Okay? Rectangular bases was probably our most common one. Maybe you did some triangular bases, but here my base is a triangle. Okay? That's why you have to identify what that base is. That's really, really important. So when I write this formula out, I'm going to do the formula for a triangle, multiply it by the height of the prism. Okay, if you want to redraw the, if it helps you to redraw it. Another really important piece is that the triangle is not only a triangle, but it's a right triangle. The base and height have to be perpendicular to one another. So as long as it's a right triangle, then one's my base and one's my height. It really doesn't matter which one's which. But when I put this into my formula, we're going to do 6 times 8 divided by 2. And I'm telling you right now, the most important or the most common thing missed here is people are going to forget to divide by 2. Okay? Over here, we didn't have to divide by 2 because it was a rectangle. Here, we have to divide by 2 because my triangle, right? 1/2 base times height or base times height divided by 2. That's why you have to identify that it's a triangle. And I'm telling you right now, a lot of people will forget to divide by 2, and you'll be like, Mr. Root, all I forgot to do was divide by 2. Well, that's a big deal, okay? That means it holds half as much as my other answer, right? If I forget to divide by 2, those two answers are going to be completely different from one another. So it's really, really important we identify the base. And what we get here is 168 centimeters cubed. Those would be our 2. So that kind of goes back to what we did on Friday. Now when we tie into what we're going to do today. Today is all about pyramids, okay? And this is what we just talked about. My base is going to be different. This happens to be a triangular pyramid. The formula for all of these is the same thing. It's the same formula that we talked about on Friday, except we take a third of it. Okay, 1/3 of that volume. If you would rather, some people like writing it like this and doing big B times H divided by 3. It's the same thing, okay? Either multiply by a third or divide by 3, you get to the same result. So however you would rather write that, we just got to make sure we divide it by 3 because it holds 3 times less than the original. Okay, but really there's no difference here. We have to identify, once again, what my base is. Big B is a triangle. That means we're using the area of a triangle formula. We're going to see lots of different examples as we go through the notes today. And you'll see lots of different examples in your assignment as well. My base here is this triangle, okay? It is a right triangle. If you want to redraw that triangle, you can. I don't know if you necessarily have to, but if it helps you to re-see that triangle separated like this, then it's okay to redraw it, okay? Some people would rather see that two-dimensional figure from the three-dimensional separated. And then the height. Here's where you got to be careful. The height of the pyramid is the perpendicular height. So it's going to go down to the middle, from the middle of the base to the point at the top, okay? And then also notice that it's perpendicular as well. So it has to be the perpendicular height. It has to be a 90-degree angle as it comes down. And in this case, it's 9. Okay? If I was putting this into my calculator, all your calculators, I know we've talked about how they're all a little bit different and how we're going to type this in. It's not necessarily wrong to put this all in at once. But just for the sake of being a little bit cleaner and easier to put in, I would do 4 times 6 divided by 2, multiply it by 9, and I would do this very last. Then I would just divide by 3. Okay? We get 36 cubic meters. So main thing is just know how to put that into your calculator. Okay. Really important today is what's the difference between a pyramid versus a prism. Prism is what we did on Friday. Today is a pyramid. It's pretty easy to identify the difference between the two. On a prism, the base comes to a point. Oh, sorry, on a pyramid. Wrote it on the wrong one. The base comes to a point above or below the base, okay? The prism, we talked about triangular or rectangular or all kinds of different prisms. We have 2 parallel bases. Whatever my base is, I got 2 of them. When I do a pyramid, I only got 1 base, okay? So that would be another thing. On the pyramid, you only have 1 base, whereas on a prism, you have 2 parallel bases. Sometimes we call that the face because it's one of the sides of your 3-dimensional figure. Okay, so it's whatever I have 2 of. So on a prism, we have 2 bases. Okay. Back in some of these civilizations, I was lucky enough to, a couple of years ago, we went on a cruise, and we got to go to an old Mayan ruin and see one of these. And the one we saw was kind of a smaller version of some of the more famous ones. But we could actually climb to the top of it, and the way these were built was absolutely amazing. I mean, it's just, they didn't have calculators and all of that, and the amount of work it would have taken to put all these slabs together. And not only that, but like all of the sides, they were a square. I mean, it was made to be perfectly square and then built up to the top. And so it was a square pyramid.
So do you think aliens
I doubt it. But
That's a theory.
I've heard the theory, but I'm not one that abides by that theory. It doesn't tell me this here, but this is a square pyramid. Okay, so we know the base is a square. So here's the big thing. We got a pyramid, okay, a square pyramid. So we got to make sure you use the 1/3. Okay, we can't forget the 1/3. That's really, really important today. This one tells me the volume. So I'm going to plug that in to V. Big B, in this case, is a square. So if I wanted to find the area of a square, what's the formula for area of a square? Okay, and what would be a way to simplify that? Because what do we know about a square? Yeah, all the sides are the same, right? So length times width works, but I'm going to show you why we would probably rather do this and do sides squared rather than length times width. Because if I don't know the dimension of any of the sides, we do know that the height is 30. We got to find the length of each side. Okay, S is what we're going to call it here. Now, there's a lot of different ways you could solve this, but the easy way here, I think, is to take 1/3 of 30, or 30 divided by 3. So this would become 30,580 equals 10s squared. We're just simplifying it, right? We're going to break it down. Now, I got to get rid of the 10. What do I got to do to get rid of the 10? Divide by it, okay? And when you divide by 10, it just knocks the 0 off on the end. Here's why we want to use s squared. If I would have said length times width, I don't know either dimension, so I can't do any division because I don't know the length, I don't know the width. But if I needed to solve for the side length here, what could I do to solve for s? Find the square root. Yeah. And so that's why we would rather use s squared than length times width. Okay, what do we get if we put that in?
55.299.
Okay.
I don't know what you
Yeah, let's just round to the 10th. Side length's about 55.3. So that's a problem where we're just kind of working backwards to get where we need to be. Okay, once again, we have a pyramid. So we're going to start off with the formula, 1/3 big B times h. Okay, anytime we have a pyramid and we're finding the volume or doing something with the volume of that pyramid, same formula, 1/3 big B times h. In this case, big B is what kind of base? It's a triangle, okay? I always kind of like to highlight the base so we can see it. In some cases, it might help you to redraw it. I think for this one, it would probably be a good thing to do because I don't know if we've seen one exactly like this. Usually, we have a right triangle here. The ones that we've seen most have a right triangle, and so your base and your height are the sides of the triangle. Here, they're not. But is 3 perpendicular to the base? Yeah, so this is my height, this is my base. Okay, so it's still a triangle and we know the base and height. So all of that is the information that we need, just doesn't happen to be a side of the triangle. Okay, and that's okay, it doesn't have to be, but the height has to be perpendicular to the base. Okay, so the formula for a triangle, let's put in what we know here. The volume is 14. They tell me that right here. Volume is 14 feet cubed. Okay, then we're going to have to put in the area of a triangle formula. Well, we've talked about that a lot. Base times height divided by 2. So that would be 4 times 3 divided by 2 and I'm trying to find h, the perpendicular height. I want the height of this pyramid. Okay, how to put this into my calculator. Once again, there's a lot of different ways that you could go about this. I'm going to show you what I think is easiest. Basically, it's just order of operations. 4 times 3 is 12. 12 divided by 2 is 6. And then we were going to take a third of 6, or even easier, 6 divided by 3. Okay, so all of that will simplify down to be 2 times h. If we multiply all that together and then divide by 3. Okay, so then the math ends up being pretty easy. 7 feet. Okay, so just be careful about how you put that into your calculator. If you don't put it in just right, I'm not going to get you the right answer. Okay, I'm not going to do both of these. We already kind of did one like this, but I do want to talk about this one here. Once again, it's a pyramid. What kind of pyramid do we have here? Square. Square is my base, right? So big B is a square. Volume is 1/3 times s squared times h. I'm going to go ahead and put in s squared because it's a square, right? So I'm going to go ahead and put in s squared for big B. This one, we do not know the volume. That's what it's asking us to find. What is the volume? We know that each side is 10 centimeters long. So that's going to be our 10 squared times our height, which is 12. So that one is just plug it right into the calculator. I still think it's easiest to do 10 squared times 12 and then divide by 3 at the end rather than multiplying by a third. But it's kind of up to you, whatever you feel is easiest on your calculator. Okay, everybody good with that? Calculators? Everybody okay with how to put that in? Okay, this one's a little bit weird, okay, a little bit different. We've got a lot of things going on here. First up, as I look at this pyramid, my base is what kind of figure? Hexagon. Yep. Do we have a formula for a hexagon? We have a formula for a triangle. We have a formula for a rectangle. We have a formula for a square. Do we have a formula for a hexagon? As long as it's regular, right? So that's the key here. Notice on the picture, all of those sides have the same marking, right? And so we know that this is not only a hexagon, but it's a regular hexagon. Okay? So that is my big B here. The good news is we get to use all the stuff that we did last chapter and bring it back into this chapter, right? It's great news, right, Ava? Not so much? You thought we were done with chapter 10, right? Chapter 11, I guess. We're going to still be using it, okay? What is the formula for a regular figure, any type of regular figure? Anybody remember it? 1/2 AP. Good. Okay. 1/2 times the apothem times the perimeter. Okay, so volume equals 1/3 times big B, which is 1/2 AP. That's my regular polygon formula times the height. Okay. I like to write the formula out with all of these variables in it so we know what we got to find. Okay. We got to find the information for all of these things. We are trying to find the volume. Okay, we already know the height, so that part's easy. The height's 20. Okay, now inside of here, the regular polygon. Each side length is 12. So that helps me find what? Perimeter. Okay, how many sides? 6, right? So 12 times 6. We're missing the apothem. We don't know the apothem. Okay? So we got to find the apothem. The whole length is 12 of the base. So when I split it, when I draw that apothem in there, it's going to split the base in half. We're trying to find A. How many degrees would this angle right up here be? It'd be 60, okay? Because there's 6 sides. So we're going to go 360 divided by 6. So each angle is 60 degrees. But when I split it, it's going to be 30, okay? This is going to split that top angle, so it's going to be 30 on either side. And guess what? We have our special triangle again. Okay? You have 2 options here. You can use your special triangles again. I told you they were going to come back into play. That's why I told you to keep those triangles, because there's going to be times where we're going to need it again. If you don't have the special triangles, then you have to use SOHCAHTOA here. Okay, the nice thing here is the side opposite 30 is 6. So my apothem is 6 radical 3. Okay? The hypotenuse would be 12, but we don't need the hypotenuse. We just need the apothem, which is 6 radical 3. Okay. So let's practice putting this one into our calculator. Here's what I would do. When I put this one into my calculator, I would multiply, and it really kind of depends on the type of calculator you have. So kind of practice with it. 6 radical 3 times 12 times 6 divided by 2, or take times a half. Multiply that number times 20, and then at the very end, divide by 3. Okay? Try putting that into your calculator. Okay? Anybody got it? Colton, what'd you get? 2,494.15. Okay. Okay. Even if you use SOHCAHTOA, you should still end up with the same answer. Okay? And that's okay if you have to use SOHCAHTOA. Everybody good with that? Anybody need help with their calculator? There's a lot of stuff. Okay? What could be really frustrating is you have all of this stuff right, but if I don't put it into my calculator exactly right, then I could miss it, right? So calculator is a pretty big deal here. Okay, I'm going to skip over the square pyramid there, and we're going to go down here to the bottom. We did some problems like this on Friday as well. On Friday we did similarity, surface area, and volume. This one is not dealing with surface area because today our focus is volume. So we're not going to see the surface area portion of it. On Friday when we did similarity, we did surface area, and we did volume. We don't need to do surface area today because it's not going to ask us about area, just volume. If you had to, you could do area as well. Okay, so similarity is the ratio of any 2 sides. It could be radius, diameter, height, length, anything. But we got to compare 2 sides on the 2 figures that match up. So in this case, the only 2 pieces of these pyramids that we know are 8 and 6. So we're going to compare the 2 heights. So I'm going to go 8 over 6. Some people say, well, can I do 6 over 8? Sure, as long as you stay in the same order. When you set up your proportion, not a big deal. Always reduce it so we have a little bit smaller numbers to work with. So 4 over 3 that's what we call our similarity ratio or our scale factor. There's a lot of different names that we use for that. If I want to do the volume ratio, I have to take this ratio we just found, and I have to cube it. Volume is always cubed, so you have to change it to a volume ratio. So we're going to take 4 to the third power, and we're going to take 3 to the third power. Okay. Some people were asking me how to do raising it to the third power in your calculator the other day. All your calculators are a little bit different. Some of you have like a little, kind of looks like a caret, where it's just your exponent button. Some of you have x to the y or y to the x. Your exponent button looks a little bit different depending on the calculator that you have. Those are your exponent buttons. Okay, so to find the volume here, we're going to use the ratio that we just found, 64/27, and we're going to set up a proportion, okay? Now, we went big over small. So when I compare the two volumes, 96 is the volume of the big pyramid. This one's bigger than this one, just by looks, right? So because this one's bigger, 96 is going to go on top, because 64 is bigger than 27. So I'm going to put 96 on top. I don't know the smaller one. That's what I'm trying to find. Okay? We set up a proportion. We've done this a lot over the last couple of chapters. Set up a proportion to help us solve. And now we just got to cross multiply. You're not always going to get a nice whole number. We're going to get a lot of decimals in this chapter. So we get about 40.5 centimeters cubed. Okay, questions on that one? I'm not going to do the second one just for the sake of saving a little bit of time, but it would be very, very similar. Okay, this last one is basically doing what we just talked about. If I have these two figures, and I take this and I put it on top of this, right? So now I've got two figures sitting on top of each other. I've got a pyramid on top of a prism. So I want to find the total volume here. I want to find the volume of this and the volume of this, and we're going to put it together so we find out how much total this would hold if I were to fill it up. Okay? So we're going to fill up the bottom, we're going to fill up the top, how much my total volume is going to be. So what we're going to do here is find the volume of the prism plus the volume of the pyramid. Okay, the prism is big B times H. What kind of base do I have on bottom? Square. Yep. So I could do 6 squared times the height, which is also 6. So it's really a cube, right? And so really what you could do here is you could just take 6 cubed, or 6 times 6 times 6. So that would be 216. So the volume of the bottom is 216 cubic meters. Okay, the pyramid on top, it's also a base of a square, okay? It's also got a square. Here's the part you got to remember. Probably the part that gets left off more than anything else is we forget the 1/3 here. We get in the habit of doing base times height, then we forget the 1/3 times base times height. Okay, they have the same base, and just so happens they also have the same height. They also have height of 6. So once again, I could just do 1/3 of 6 cubed, or 1/3 of 216. So it's just 216 divided by 3. We add those two together, and we get 288 meters cubed. Okay, I don't think we need to do the bottom one. The bottom one would be very similar. The only difference there is it's a base of a triangle. And so you just gotta remember your base is a triangle there. Also, the heights are not always the same, like on this one, the height of the bottom is 5, the height of the top is 3. This one up here, they happen to be the same height, but that's not always gonna be the case either. Okay. All right.